Hi, this is Mr. Nazarian. Our lesson objective today, I can understand and explain the value of digits in a larger number. It's 5th grade standard, numbers base 10A1. This one is going to be a review for many of you, and that's okay because this is a really important one to make sure that we feel strongly about before we have the fun of jumping in and challenging ourselves with the rest of 5th grade math. So, if you were to guess what the number one mathematical mistake that students make from kindergarten through 12th grade, what do you think that would be? If you guessed place value, you're right. So what is place value? Why is it important? So the first thing we need to remember is that we use a base 10 number system in math. So what does that mean? Well, our numerical system is made up of 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's an infinite amount of numbers in our number system, but they're all made up of some collection of these 10 digits. The value of each digit depends on its place in a number. So, if we look at this digit here, 2, in the number 432, what is the value of the digit? It's 2, right? Not too bad. But if we look at this number, quite a different number, but we look, here's a 2 again. So the value of this 2, of this digit, is what? It's not 2 because of its place in the number. The placement of this digit in the number 2568 is in the thousands place. So the value of this 2 is actually 2000. So we're going to look at a place value chart, which looks like this. I'm sure you've all seen this before. And place value chart breaks down all the place values for us, and it always on the right side, well, until we start working with decimal places, the first one that's farthest to the right but left of the decimal point is the ones place, right? And then we have tens, hundreds. Then we have here the thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, and it goes on and on and on, but we're going to stop with that today. And so the pattern that I'm sure you've seen before is that in each one of these kind of collections, maybe your teachers call them houses, families, is that it always goes ones, tens, hundreds, ones, tens, hundreds, ones, tens, hundreds, because even though this says thousands, it's really the 1000s place. The only difference is here I put first name basis because we just say this is ones, this is tens, this is hundreds. There's not really a last name. This one, all of the three place values here all have thousands in the last name. The 1000s place, the 10,000s place, the 100,000s place. So we're a little bit more formal with these. And the other thing that you will remember is that we put a comma between these groups or houses, whatever you want to call them. It's kind of like a fence in between your neighbors. So that's why we always have those commas. All right. So we're going to look at a few different numbers. So that those first two numbers we put up there, 432, was that number right? And remember we said that 2, the value of the 2, because it's placed in the ones place, it was only worth 2, right? So 2 in the ones is worth 2. Now here we have a 3 in the tens place, and 3 tens is worth 30, right? And 4 hundreds is 400, so we have 432. The other number, 2,568, we have 2 in the thousands place, 5 in the hundreds, 6 in the tens, which makes 60, and 8 ones is 8, right? And again, we can put a comma in between the thousands and our first name basis group here. All right. So something else about the base 10 system is that you only can have one single digit in each place value. So if we had 9 here, we have 9 ones. But let's say that I added 3 to that, then we would have 12, correct? Well, I can't have 12 in the ones place. Because I can't have 2 digits in one place value. So what we do is, of that 12, that's made up of a 10 and a 2, so that means we have 1 in the tens place and 2 in the ones place. So that's something important to remember. And finally, something to remind ourselves about is that if I had a 1 in the ones place, that's just 1, right? But what if I had 110, right? How many times bigger is that? How many ones makes a 10? 10 tens, right? And think about, well, if I had, okay, let's say I have 1, 2, 3, 4, I have 10 tens, that would give me 100. So there are 10 tens in 100, right? So what, and then if we count it up by hundreds, 100, 200, 300, and so forth, 900, what is 1000 equal to? You guessed it, it's equal to 1000, right? So the pattern that we should see here is that every time we moved from one place value to the left one place value, so we move from here to here, here to here, it gets 10 times larger, right? So let me just move this. So 10 ones makes a 10. 10 tens makes 100. 10 hundreds makes 1000, excuse me. So every time that we move to the left one place value, it gets 10 times larger. Okay, and last thing for today, we're going to look at expanded notation, which goes along with place value. And this is going to be really useful for us as we look at some of the different strategies for multiplying, which we'll start in our next lesson. So when we look at this number 8,523, this digit here, this 8, remember it doesn't represent 8. What does this 8 represent? What is the value of that 8? It is 8,000, right? So we have 8,000. And this 5 is not really a 5, right? Because it's in the hundreds place. So it is worth, what is the value of this? It's 500. The 2 is in the tens place, so 2 tens, whoops, 2 tens makes 20. And 3 in the ones place gives us 3. So 8,523 means is made up of 8,000 and 500 and 20 and 3. So we're going to use this expanded notation as we work on some different strategies with multiplying multi-digit numbers next time. All right, so see you then. Can't wait to work on this tomorrow. See ya.